calculator, it would be 10.909 or something like that. And then you know last time I showed you, right, how to get the remainder. Okay, multiply this by 11, you should get 10. Okay, multiply the fractional part by the divisor and you get the remainder. Right? So, then what's your x?
0 times
1 minus
1 minus 10.
So that's going to be 1. What is the other one? Y.
0 minus 10 times
What is that?
10.
Negative 10. So this is one iteration. Right? So now let's do the second iteration. Someone else over here?
So it'll be 1,
What's the first step?
go up to above.
11
By
divided
the
by
quotient. So what's your quotient?
1.
1.
11 divided by 10, right? So this is your m and n now. So 11 divided by 10, the quotient is 1. Right? The remainder is 1. Right? So what is your x and y?
1 minus 1,
Go
go up to
So our two steps means what?
0,
0, then
minus 1,
1 times 1.
0 minus 1 times 1 is, then
um,
Then you go up 2 for y.
1 minus 1
Times 1.
times 1 times 10.
Oh, that's negative 10.
Yeah,
Right.
it's negative 10.
Oh, okay. I see it. So that's 1 minus a negative 10.
That's 2.
That's a negative.
9 or 11. 1 minus 1 times negative 10. 1 minus negative 10, right? 1 times negative 10 is negative 10.
That's what I said. Negative.
You said 9.
Oh, okay.
Then 1 minus minus 10 is
Negative 11.
11, right? 1 plus 10 is 11. Okay? Alright, so now
10 times 1,
quotient
10.
10 times 10 divided by 1, quotient is 10,
10.
what's the remainder?
0.
So, are you done?
2 up.
So, what is the x and
Oh, you
y?
can stop at 0.
Right, you stop at 0. Good.
Oh,
So, what's your x and y?
X is negative 1, Y is 11.
Or what are we interested in, x or y?
y.
Y.
Y, because you're multiplying 25 multiples of 11, right?
Right.
We're interested in y. So that's why you see 11 is the multiplicative inverse of 11. It's just coincidence, so not always the case. In class modulo 120. Why? Because 11 times 11 is 121. So 121 mod 120, the remainder is 1. Okay? So in this case, it turns out that 11 is also the decryption key. So your encryption key is 11, comma, the n is 143 p times q. Alright, and the decryption key is what we found, 11 again, times, comma, 143. So this is how you determine the encryption and decryption keys. So one of them could be your public key, and the other will be your private key.
But we could have chose the other numbers to make it. It's just that was our choice, either
Yes.
one.
So whatever you choice is normally a public key, and the private key is derived based on the public key. Okay, and that's what you will do in your project also. Alright, so now, so what we did right now is to find the encryption key and decryption key. So how we do the actual encryption decryption, we saw that, right? Do this modular exponentiation. Right? So, what we found is the encryption decryption key. So now given say a plain text, say 3 and we need the value 7. So always we work in this course with integer values of plain text. So it is 7. So I want to encrypt 7 and get my ciphertext. So my encryption key is again 11, 143. So I want to find 7 raised to 11 mod 143. Alright? So how do we do this kind of modular exponentiation? So factorized is 11. So when I factorize this 11, not factorize, try to write the exponents of 2. It's 1, 4, 2, 8, right? So don't go beyond 8 because the next exponent is 16 and it is already greater than 11, right? So 1, 4, 2, 8, and you have to find basically 7 raised to 1 mod 143, 7 square mod 143, 7 raised to 4 mod 143, 7 raised to 8 mod 143, right? So 7 raised to 1 mod 143 is going to be what? 7 raised to 1 mod 143 is going to be 7 mod 143, that is 7. So anything divided by a larger integer is that integer itself. Okay? And then you want to find 7 square mod 143. What is 7 square? It is going to be 7 times 1 times 7 times 1. That's what you did, right? 7 square is 7 raised to 1 times 7 raised to 1. And we know 7 raised to 1 is 7 in terms of mod 143. So it is 7 times 7 mod 143. It is going to be again what? 49, less than 143. So now we want to find 7 raised to 4 mod 143. It's going to be
7
square
Right.
times
7
square
squared.
mod 143. So all you have to do is now substitute 7 square mod 143 is 49. Okay, so take this mod operator inside, it is 7 square mod 143 times 7 square mod 143, right? I can take this mod operator inside, right? So if I take it inside, it is 7 square mod 143 times, that's what I should have done here too, but I just assumed you figured it out, right? So this is 7 square mod 143.
And just multiply together.
Yeah. So the whole thing again, if it exceeds 143, you have to take the mod 143, right? So you typically take the mod until you get something between 0 to 142. So this is going to be what? 7 square is 49, right? In terms of, yeah, 7 square mod 143 is that. So 49 times what? Again a 49 mod 143, right? Okay? So it is 49 if you want one more step. 49 mod 143 times 49 mod 143. So that comes out to be what? 49 times 49. But you know 49 times 49 is going to be more than 143. So that's why I said do a mod 143. So what is that? Calculator. 49 times 49 is going to be 2000. If you don't mind.
2,401.
Oh, I have it there. Alright, but let me hide it. You need to know how to do this. Quick, we need to finish it. Nobody has a calculator?
Yes, I just
2,401,
And do the division and tell me the answer.
113.
Are you sure? You can proceed?
Do all that, you sure that's right?
Yes. If you made mistake, then everything will go wrong. Somebody else has to confirm.
here. Your calculator. I'm just gonna confirm for you.
Why I got it?
Cause I can't do it with my hands on one hand. I can't even text with one hand.
Yeah, that's, okay,
Tell me the whole number, what along with 16?
16.
16 dot, sorry, point
179.
79 something, right? So how do you find the remainder? Multiply this 0.79, whatever it is, by what? 143. So you should get close to 113, right?
Mhm.
Yeah.
Okay. Everybody understood this is how you find it?
Yes.
Okay. So 113. So now, what is that we're going to find? 7 raised to 8 mod 143. So that is 7 to the power 4 mod 143 times 7 to the power 4 mod 143. So that is equal to, so now we know that 7 raised to 4 mod 143 is 113. So I'm skipping the small intermediate steps. So this is 113 times 113 mod 143. So somebody should quickly do and tell me what is the answer.
12,769.
12,069.
12,769.
Okay, mod 143. So 89.29 something, so now it is going to be active reminder. So it comes by practice. So if you take this much time in a quiz or exam, you won't complete that. Okay? Practice.
Let me see calculator.
134? 42? Okay, this is not still the final answer. So this is 42. Okay. So what do you want to find? 7 raised to 11, right? Then you want to encrypt that, isn't it? This is the only thing I like in this room. I can keep on writing. 7 raised to 11 mod 143. So this is where you need to decide which of these things you will make use of. And that's why I wrote this 11 in binary. Right? So 11 is what? 8, 2, 1, right? So 1, 0, 1, 1. So I need to use 7 raised to 8 more, and then 7 raised to 2, 7 raised to 1. So this is going to be 7 raised to 8 times 7 raised to 2 times 7 raised to 1 mod 143.
See, that's the part that had me confused.
Right, is that clear now?
Yeah, it's clear now.
So we found each thing. So 7 raised to 8 was 42. 7 squared is 49, 7 raised to 1 is 7, mod 143.
Why, Chris, I'm sorry, why wouldn't you say the, to the fourth, I mean.
Why
seven-
would you?
Because it's no zero there. It's not a 1 there. It's only a 0 when you do the
Right,
binary.
binary.
Okay.
And these are the exponents of 2, the corresponding exponents of 2. So it's basically writing 7 raised to 11, this is what it is, right? It's 8 plus 2 plus 11, adding exponents you get 11.
Right, okay, that's why then why we had, we had to calculate the distance. Okay.
Right, to get 7 to 8, we need to find 7 raised to 4. Alright? So now, you don't need to multiply the whole thing and work with a larger integer. What you can do step by step. Anyway, you're doing 2 multiplications, right? But you can minimize, you can work with smaller integers by doing what?
My
Find 42 times 49, and whatever it is, take what? Mod 143. Anyone has the answer?
Give me a calculator.
That is
Shanique.
56. So 42 times 49 will be some larger integer, I think it's 3600 something. Mod 143, 56. Okay? And then you have the 7, right? So this is 7 mod 143. This 7. And it comes out to be what? So 106, 392 mod 143 is 106. Right? So this is a cipher text. So what we did, we computed 7 raised to 11 mod 143. 7 was your plain text. And we computed 7 raised to this, and we got this as a cipher text. So now we want to decrypt, right? Decrypt means what? In this case, the encryption key are the same, but ideally they need not, generally need not be the same. So 1 was 6, 11. This is your encryption key. This is your decryption key, right? Mod what? Again that 143, right? What should we get? Plain text 7. 1 was 6, the cipher text, rise to 11, mod 143, should get back your 7. If you did right. Okay? So I have that there, so practice it.
So 7 is the decryption key,
7 is the plain text.
the plain text.
And 106 is the cipher text.
106 is the cipher text. Right? So 11 both encryption, decryption key. But the other example, second example, you see these two are, this is the encryption and the decryption key. Right? So I also have worked out another example where the plain text is much larger, 127. The encrypted you get 213. And then 213 if you decrypt with the right key. What is the right key? 325 mod 391. You should get back 127. So go home and work both these problems. Make sure you understand. And Wednesday